Okay, if you want to go back to the original description of this problem, it's basically there's 10 different tasters who are tasting a cola, and they're tasting two versions of it, one that's fresh and one that's been stored for some period of time, that's been sitting around for a while. And the question is whether or not the cola has lost sweetness. So it specifically wants to know if in sitting over time the cola has lost sweetness. So we're going to go through the 5 steps of the hypothesis test here. Step 1 being trying to find the null and alternative. So if there's no difference, if the cola does not lose sweetness over time, we would expect our average to be 0. And let me remind you what was being tested here. So the taster would taste both the old version and the fresh version of the cola, rate both of them on a sweetness scale. By the way, the taster didn't know which was which. There was a subtraction, and the positive numbers would mean that it lost sweetness. The more negative is would mean that it gained sweetness. So if it hasn't changed sweetness at all, the average would be 0. If it's lost sweetness, because these positive numbers, the more positive is, the more the tasters are saying that the cola has lost sweetness, then we would want a positive mu, something greater than our null hypothesis mean of 0. Step 2 is setting up the targets. So we're going to assume an alpha of 0.05, something a little different from the z-test. Finding our critical z, we're going to have to use table C. We're going to need a couple bits of information there. One is we need to know if it's a one-tailed or two-tailed p-value of 0.05. And in our case, because we're saying the alternative is that it actually lost sweetness, it's greater than 0, we're giving it a direction, we're going to just have one tail. Essentially, we're putting the entire 5% of rejection in the very top instead of splitting it across the two. We also need to know degrees of freedom. So for this problem, the sample size was 10. 10 minus 1 gives us 9 degrees of freedom. And let's look that up. Okay, in table C here, we're going down to the bottom. Notice these two rows, the one-sided p, the two-sided p. We've already determined we're dealing with a one-sided p of 0.05, so that locates our column that we're going to find our critical value in. And we know our degrees of freedom is 9, so we're going up to the row with 9 degrees of freedom to get 1.833. So again, what that is, that's a cutoff. That's a value we can determine before we actually even look at our data, and it tells us where our t-statistic is going to have to be if we want to reject the null. It's going to have to be somewhere here greater than 1.833. So if we run through the calculations, it should look very similar to the z-test statistic, with the difference being we now have the sample standard deviation rather than the population standard deviation of sigma. When you plug all that in, you get 2.697 as your particular t-statistic, and we can use this to find our p-value. Again, we need to remember a couple things. We're dealing with a one-sided p, 9 degrees of freedom. So let's look up where that 2.697 would fall. Okay, this time we kind of work backwards. We start with our 9 degrees of freedom, and we need our 2.697. We're not going to find it in this chart, but what we want to find is what two columns is it between. So 2.697 is going to be between these two columns right here on the row of 9 degrees of freedom. So let's stay in between these two columns, and we go down to the very bottom two rows. We could check here if we're dealing with a one-sided, here if we're dealing with a two-sided. In our case, we're dealing with a one-sided. So that particular value would put us somewhere between a p-value of 0.01 and 0.02. We don't know what it is exactly without using technology, but we're somewhere in between these two numbers. So we record that p-value. Step 4, we need to decide what to do with the null hypothesis. We can look at this two ways. 1 is our p-value less than the alpha of 0.05? And yes, it is indeed, even though we don't know exactly what it is. It's somewhere between 0.01, 0.02. Wherever it is in that range, it is less than 0.05, so we can reject the null. We could also look at where our specific t-statistic fell in the scheme of things. So we needed to get into, back in step 2, we had set up that rejection region, anything higher than 1.833, and our sample was indeed inside that rejection region. It was 2.697 was our t-statistic. And so either way you look at it, we do reject the null hypothesis, meaning that if we're rejecting this, then we're going to assume this. We haven't proven it, but we're saying that our study does give evidence that this particular cola loses sweetness, not just for these 10 samples that were taken, but in general, assuming that our sample was random, we've now shown that in general, we have evidence that this cola does lose sweetness.